So, good morning. Myself, Dr. Lingaraju, Government First Degree College, Tumkur. So, in physics, today we will discuss expression for numerical aperture. It is a very important question. So, learning objects of this concept is to understand the derivation of how to derive the numerical apertures. Expression. So, after knowing this one, we can understood about a acceptance angle, how many propagations we can send it to the signals, so what it needs, what are the importance, all these things here we are getting from the learning outcomes. So here we are going to consider two different refractive index of a materials, that is a core and cladding refractive index. It is in the form of a circular order, that is nothing wire. Here core having a certain amount of a refractive index and it is a constant. Cladding is having a certain amount of index, it is also constant, but your core say N1, it is a more refractive index compared to cladding refractive index. At the time, here from the outside, if the light radiation will be sent means, so here outside means it is a air medium. It is called as mu naught refractive index. Core we can say N1 refractive index. Outside N naught, core N1, cladding N2. From the air medium, that is N naught refractive index, the light radiation will be incident. The incident light radiation will be take the refraction because of due to the variation of refractive index in the core medium. This refracted light radiation will be incident at the interface of core and cladding. Depends upon the angle of incidence, the light radiation will be in one particular angle gets scattered, comes out from the optical fibers. If the variation of acceptance, variation of the angle of incidence means, so the refracted light radiation will be graze the interface of a core and cladding, where that particular angle, that one is we called as a critical angle of acceptance. Of knowing the critical angle of acceptance, just above the critical angle of acceptance, we have to send the readings, or we have to send the proper light signals. It takes the total internal reflections in the core mediums. So once it is take the total reflection in a one particular core and cladding medium, the light will be gets reflected. The refracted light radiation will be is going to become an incident light radiation at the another interface. At the time, it takes the total reflection once again. Like that, multiple total internal reflections taking place in the optical fiber, the light will be moves from one place to the another place. So after knowing this concept, we are going to discuss all these things through the Snell's law. So in the Snell's law, here we are going to discuss in the first concept, n naught sin theta naught is equal to n1 sin theta 1. So this is the air medium, this is the core medium. So here it becomes to sin theta naught is equal to sin theta 1. So numerical aperture is equal to n1 by n naught of square root of 1 minus cos square theta 1 by the refraction at B. So n1 sin 90 minus theta 1 is equal to n2 sin 90. That is n1 cos theta 1 is equal to n2. That means refraction index of a core or cladding into 1 or cos theta is equal to n2 by n1. So it becomes numerical aperture is equal to n1 by n0 square root of 1 minus n2 square by n1 square. So we can simplify these equations in this form. Numerical aperture is equal to square root of n1 square minus n2 square by n0 of the optical fibers. Now after knowing this one, n0 means it is the refractiveness of the air medium. The n0 is equal to 1. So far the equation is numerical aperture is equal to square root of n1 square minus n2 square. n1 is refractiveness of the core and n2 is refractiveness of the claddings. So we know that the ray will be able to propagate if theta I is less than theta naught or sin theta I is less than sin theta naught. That is, sin theta I is always less than numerical apertures. So this is the way here we are going to express the expression for the numerical aperture concept. After knowing the acceptance angle, so any signals if we send it through the acceptance angle, so all the light radiations will be takes the total internal reflections. Then it moving or it takes the propagations from one place to another place up to 1,000 kilometers without any loss of intensities under the total internal reflections. So next year we will discuss multiple choice questions. Next, first one is numerical aperture is expressed as numerical aperture is equal to cos theta A. So second one is the technique by which image is obtained from the hologram is construction method. So third concept is which of the following is used for the formation of holograms? That is lasers. So is it not possible to break hologram in small pieces? No, it is not possible to break small pieces. That is a very important concept from the holograms. Holography records dash of light coming from the object. That is both intensities and also in a phase. So both in these two, it is going to collect and give the information about the hologram stickers. So it's about numerical aperture expression and also some basic concepts about the hologram concept. Thank you one and all.